All right, this is chapter 6, test review. There's going to be 30 questions on the test. 20 of them are multiple choice, 3 points each. 10 of them will be free response, and they'll be 4 points apiece. I will give partial credit, and the free response questions will be same kind of questions that we're about to go over here. All right, guys. The first lesson, 6.3, was about graphing square root functions. Just looking at this equation, what can you tell me about it? Anybody? It's transformation. What can you tell me about it? Sorry, there it is right there.
So you go left.
It's going to go 5 to the left and 3 what?
Down.
Down. And that's where the starting point is. Remember, square root functions look like a little, I don't know, dog tail. All right, so let's take a look at it. So x plus 5. Remember when I'm typing this in, x plus 5, then I have to arrow outside of the square root bar. What did I say, minus 3? What?
You didn't put in y.
Oh, duh, Coach Larson. Whew. Let's get started off on the right. Oh, someone's got my stat plots on too. Let me turn those off. Okay, here we go. Square root of x plus 5, arrow out, minus 3. Here's my little graph. Everybody see it? There's the starting point, shifted 5 over and 3 down. Yes? Let me graph that real fast. Remember the points that you'll be able to plot. Where's that minus 3? You'll have to like scroll through the table, right? So lots of these are going to be irrational. Okay, here we go. Pretty easy, right? And then the next part is domain and range. Okay, what's going to be the domain in this graph? Where does it, yeah, look, Matt's going like this to himself. So the domain are the x values. Where do the x values start?
-4.
-5. What's the left bound on the domain? It's -5, correct?
So
It gets a bracket. What's the right bound? Infinity. Parentheses, very good. And then the range of the y values, so the
-3.
bottom bound and the upper bound. So where does it start on the y-axis? It starts at
-3.
-3 and goes what?
Infinity.
Infinity. Remember, if I look in my table, let's go back here to the starting point. Do y'all remember this? All the errors. Here's that very first point. So the domain is going to start here, and the range is going to start here. If you don't like doing it visually on a graph, if you don't understand that, just go to the table. This is the very first point in the function that you can plot. Domain, -5 to infinity, or the range, -3 to infinity. Okay? All right, 6.4 is our first little lesson about simplifying these roots. Am I on the screen up here, people? Okay. No, I'm not. Here, I gotta scoot this over a little bit. Okay, this is a 4th root, so I'm looking for groups of 4. Okay, really? So this is like 8 of these multiplied together. 6, 7, 8. I think most of you guys figured out this little shortcut. How many groups of 4 are there? 2. So that would be a squared. And what if I had b to the 12th? How many groups of 4 would there be? 3. Are there any left over? No, so that would be my answer. There's none left under the root because they're all grouped together. Number 48, this is a 5th root, so we have to look for groups of 5 like factors. This one actually has a value, so I'm going to have to break it down. I'm going to go ahead and break it down, though, Mr. Seegers. So 243 let's see, 243 divided by 3 is 81. 81 is what, 9 and 9? Oh, looky here, people. How many 3s do I have? 1, 2, 3, 4, 5. Correct? So I pull that to the outside, that's 3. Are there any left over?
Nope.
Nope.
X squared, y to the 5th.
Uh-huh. So you could probably do this in your head. X to the 10th, how many groups of 5 are there? 2. And y to the 25th, how many groups of 5? 5. Any leftover factors? No. Pretty simple concept, yes? Just make sure if you have any leftover factors that you can find them in your work over here. Okay, groups of 5, groups of 4, whether it's a constant or a variable. All right, moving on. The next was add, subtract, multiplying, and dividing radicals. Let's look at number 52. Okay, this is a multiplication question, and because these are the like roots, I can multiply them together and then simplify it. To me, I think that's easier. Okay, so let's find the product of this first and then multiply it together. So 4 times 3 is 12. Square roots of, what is that? 42. X squared, y squared? Y, yes. X squared, y squared, does everybody agree? I can multiply these together, they're the same root, okay? So now can you simplify this just like we did in the previous 2 questions? Sure, square root of 42, 2 times 21, 3 times 7. Oh gosh, do we have any pairs of terms? No, this was a good question for me to choose. What do you do if you don't have any like factor groups? It just stays, you can't simplify it anymore. It's just like a fraction. It can't be reduced any farther. Okay, but x squared, y squared can. Square root of x squared is x. Square root of y squared is y. So my answer would be 12xy square root of 42. Okay, I multiplied everything together. I tried to do the factor tree of 42, but there are no pairs of like factors. Take the square roots of those. 12xy, square root of, that's a 2, 42. Good? Okay, the next one is, oh, this is a great question. Can I add and subtract these just like they are?
No.
No, they have to be you like radicals. They have to be like terms. Let me write the problem down first. So 6 square roots of 72 plus 7 square roots of 98 minus the square root of 50. Hi. How do I get them to be like terms?
Simplify.
Simplify them, right? Square root of 72 is 2 times 36, and this is 6 times 6. Is that a pair? Like pair? Yep. That pair equals just 1 6. I pull it on the outside, but there's already another 6 there. So 6 times 6 square roots of, what's left over? 2. All right, square root of 98 is 2 times 49. 7 and 7. Pair of like factors, right? Yeah, I haven't done, right here? Yeah, I'll do that in just a second. But yes, you're right, I didn't. Okay, pair of like factors is a 7. I pulled out that 7. There's already a 7 there. Square roots of what's left over? A 2. And then square roots of 50 is what? 2 times 25? 5 and 5. So pull out a 5. What's left over? 2. Oh, look, we have all square roots of 2. All right, so this one ended up to be 36 square roots of 2 plus 49 square roots of 2. Am I on the screen over there? Okay. Minus 5 square roots of 2. Are these all like terms?
Yes.
Yes, they are. You used to add and subtracting as if they were a variable. This would be like 36x plus 49x minus 5x. You just put them all together. What do I get?
80 square root 2.
31, 80. Thank you. 80 what? Square roots of 2. If they weren't all alike, you would add together the ones that were. Okay, that's what, 40, 44, yep. Questions about how to approach that question? Pretty simple breakdown too, isn't it? Pretty simple. Just remember, whatever you pull out over here, if there's a number on the outside originally, it's a product of those two things. Okay? All right, next question is number 54. Woo, all right, I'm gonna have to write this on another piece of paper, I suppose. That is 6 square roots of 5 minus 2 square roots of 2 times 3 square roots of 5 plus 4 square roots of 2. That's number 54. Everybody take a second to write it down. Okay, I have to FOIL this. Yes? Directions aren't going to say FOIL. I hope by now you would recognize that this is a FOIL question. I'm going to write it all out. So I've got 6 square roots of 5 times 3 square roots of 5. Okay, I can do this in my head. So it's going to be 6 times 3 times 5. The roots multiplied together just make a single 5. So 6 times 3 times 5. Anybody? 18 times 5 is 90. 90, Matt? Or, I'm sorry, Michael. I do that all the time. 90. Okay, the outside terms look like 6 square roots of 5 times 4 square roots of 2. Guys, what's this product? 24. Can I multiply these together? Yes. Yes, you can. This product, guys, is 24 square roots of 10. I can multiply them together. Remember, when you break them down, you take it back to its parts, so. All right, inside terms. Negative 2 square roots of 2 times 3 square roots of 5. What's the product? Negative 6 square roots of 10. Then the last, negative 2 square roots of 2 times 4 square roots of 2. Okay, again, I'm going to do this in my head. The constants are negative 8. The roots multiplied together is just a 2. So negative 8 times one more 2. Negative 8 times 2, negative 16. Okay, looky here, guys. Do I have like terms in my FOIL? Yes, I always do. And then these are going to be like terms. So all together, I should have 70 plus 18 square roots of 10. When you do your question on your test, hint, hint, in the free response, okay, I will give you partial credit if I can follow, like if you missed like one of the little numbers, but I got to be able to follow to see, you know, if you write it all out, like more likely to give you partial credit if you missed a little part. Okay. All right, moving on. Now I'm on this one, our favorite. What do I have to do to these guys? What's it called? Yes, I have to rationalize the denominator by using the conjugate. Everybody see the question? Yeah, I'm gonna write it up here. I think it's this. Square roots of 3 over square root of 5 minus square root. You're gonna have another question like this in your free response as well. Ready, Freddies? Okay, what is the conjugate? Oh.
Square root plus.
Square root of 6. And then the numerator has to be the same. That's where a lot of people make their mistake. They try to put this same thing on the numerator. The denominator and numerator have to match. This has to be a value of 1. All right, so people, I have to FOIL the denominator and I have to distribute the numerator. Here, I'm going to write it out just so you can see what I'm going to do. Did everybody recognize that I'm going to distribute the numerator and I'm going to FOIL the denominator? It's easy FOIL though, guys. This is easy. This is what I'm doing mathematically. Yes? All right, numerator. I can multiply these roots together. They're square roots. They're the same root. Root 2, I can multiply them together. So that's the square root of, where am I going to write this? Down here? Square root of 15 plus, what's this?
Square root of 18.
Square root of 18. Now, these can be simplified, but I'm not going to do it yet. Right? This breaks down into 3 and 5. This breaks down into, I can simplify this farther, but I'm not going to do that yet. All right, the bottom. Square root of 5 times the square root of 5 is just 5. The first term is just 5. The inside is negative square roots of 30. The outside should be positive square roots of 30, right? Aren't those going to cancel out? That's what we want to happen. And then the last terms, negative square roots of, oh, I'm sorry, square roots of 36, which is just 6, so negative 6. The denominator is always going to come down to just a constant. That's what you want to happen. You have rationalized the denominator and taken out all those radicals, and it's come down to just a constant. So the denominator looks like is just what?
-1.
Negative 1. Okay, what about my numerator? I have to simplify these, yes? Square root of 15 cannot, because it's just 3 times, that's just 3 times 5. What about the square root of 18?
3 times 6, 3 times 2.
Or 2 times 9, right? Which is 3 and 3. So this simplifies, either way you do it, you'd get the same thing. This simplifies into 3 square roots of 2. That is my answer, guys. Those are not like terms. One of them is a 15 and the other one is a 2. They're like roots, but they're not like terms. So again, I'll give you partial credit if I can follow, say you forgot to simplify this down. If I can follow your work, I'll just circle that part, but -1. Okay? Question about that? Pretty straightforward. All right. Oh! Next page. Now I'm on 6. I'm on 6-6? Yes? All right, here we go. Ready? Stay with me. Oh, I love these. Okay, are we ready? I'm going to zoom in for y'all too. This is a pretty good question. How am I going to rationalize the denominator?
Multiply by
Square root of 4 how many times?
5.
5 times. 5 times. There's 1. There's 2. There's a 1, 2, 3, 4. The first one counts as 1, so 1, 2, 3, 4, 5. And what is that number? 4 times 4 times 4.
56.
How much?
256. Times 4.
256? So the fifth root of 256. It's going to be a perfect root. I'll do that in my calculator in just a second. Okay? I have to multiply the numerator by the same thing. 1, 2, right? Value of 1, value of 1, value of 1, value of 1. Okay, so in my calculator, I'm doing 64 times 4 times 4 times 4 times 4 and getting the fifth root of what? Anybody? 64 times 4 times 4. 1, 2, 3. 16,000, is that what you said? 384. I know the numbers. Oh, I'm so sorry. Y'all got to tell me I'm off the screen. Sorry. I had this zoomed in pretty hard, didn't I? All right, there we go.
Coach Larson,
Yeah.
I got 1,024, not 256.
Yeah, that's what I got too, from the bottom.
1, 2, 3, 4, 5. Okay, thanks. 1, 2, 3. I agree. Thank you. Is the numerator correct? I think you just missed one. Is the numerator correct? Everybody understand the idea of what I'm doing? This is a fifth root. So I have to multiply it together 5 times. The first one counts as 1. 1, 2, 3, 4, 5. So I just have to do this math in my calculator. I've showed you how to do that, right? And actually, someone showed me a shortcut of how to do it. I always put the 5 in first, like this. Then math. Then you go down to number 5. And when you press enter, it's going to take that value you typed in and put it in this little spot. 16,384, is that my number? What we got? Why? For reals? Is that what it comes out to be? It's not perfect?
No.
Oh, that's a bummer. The other one's going to be, right? Oh, shoot.
Yeah, it's fine.
It's going to, yeah, of course the bottom one is. So this is 4. Oh my gosh. What was the top one?
2 square root 62, I think.
2 what? Square roots of what?
62.
2 fifth root of what?
Fifth root is 62, sorry.
60 what?
2.
Okay, and how'd you get that?
I just factored it.
Factored all these down?
Yeah.
Exactly. Now, to me, it would be easier, instead of trying to factor this large number, it's kind of already broken down into factors right here, isn't it? Yeah, isn't it? Yeah. 64 times 4 times 4 times 4 times 4. So 2 times 2, 2 times 2, 2 times 2, 2 times 2. 8 times 8. Got it? I think the one I gave you on your test is not to the fifth root, so that number's not going to be quite as big. Okay? And in fact, I think this question on your test is a multiple choice question. Okay? Everybody understand the idea, yeah?
I got 4 square roots, or 4 fifth roots of 16. Did you use 250?
Here, let me do it real fast.
No, I used 16.
64 is 8 times 8, which is 4 times 4, 2, 2, 2, 2, 4, 4,
It's 4 fifth root of 16.
2, 2, 2, 2, 2, 2, 2, 5, 1, 2, 3, 4, 5. Hold on, I'm trying to do this real fast.
14.
4, 5. 1, 2, 3, 4, 5. What was the other value y'all got?
4 square roots of fifth roots of 16.
2 to the 14th power is 16. 60,380.
What is?
Two.
2 to the what?
14.
2 to the 14th? Yeah, so that's what I did, look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, 14th power. 14th or 16th?
14.
That's where I messed up. Okay. Oh, so I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4 fifth roots of,
16.
yes, 4 fifth roots of 16. That's what I got. Okay. Again, I think the problem I gave you on your test isn't the fifth root. Does everybody understand how I got to that point? Though the simplify, you'd have to like really work on a little bit. Okay. All right. Number 15. Everybody see this on the? Can I write that a different way so it doesn't?
Square root.
Can I write those with square roots? Would that be a little bit more pleasing to the eye? I think it would be too. So I could rewrite this as the square root of g minus 1 over the square root of g plus 1. That's the same thing, correct?
Yep.
To me, I'd rather see it like this than like this.
Then we
Because now I'm going to multiply by the what?
conjugate
Conjugate. What is the conjugate?
G.
Square root of g minus 1. To me, I just like the way this looks better than with the fraction exponents. Everybody understand the process of what to do? Yes? I'm not going to work this all the way through. I'm just going to kind of give you the denominator is going to end up to be g minus 1. Square root of g times the square root of g is just g minus 1. The middle terms cancel out. The top is going to be, I think I can do this in my head, g minus 2g, 2 square roots of g, plus 1. When you FOIL it out, if you want to try to do that on your own, this is what you should get. I cannot cross these out. This is in its nice little own group. I just wanted to show you this to make sure that anytime it's written as a fraction exponent, you can always write it as its radical to do the problem. Okay, same thing as before, it's a conjugate. FOIL the top, FOIL the denominator. All right, moving on. Oh, look at this question. The directions would say simplify or evaluate. 6th root of 81. Yikes. 9 and 9. There's nothing, is there? Oh, I think that's why I picked this question. Is there a group of 6 like terms? No.
That's just the same.
What about g to the third? Guys, g to the third is just g times g times g. Are there 6 of them? No. So what's the answer?
81G.
This cannot be simplified any farther. All right, on this page, I copied all the questions, I think. Specifically, I picked out these 3. But if you look at this one, do you understand you would add the exponents together? Oh, thank you. Where am I? Okay, here we go. Oh, I got off a little bit. Am I on the screen for everybody? Do y'all see that on this one I would add the exponents? Yes, add the exponents, the fractions. You can do it in the calculator. This one, same thing, yes? Add the exponents. You do it in the calculator, the math. What about this one? What do you do to them? Multiply. B to the 3 over 12, which is the same thing as b to the 1/4. Make sure you simplify them. Multiplying the exponents, ones like this, you would add the exponents. Do we need to go through this kind of problem again? No. What about, oh, I do need to show you. Let's talk about this one. What if it's a negative exponent? You have to rewrite it as 1 over d to its positive 5, 6. Can I do anything with this? No. If this were a number, I could try to evaluate it. Anytime it's a negative exponent, this is like one of those basic exponent rules. You write it as a reciprocal with a positive exponent. Okay, guys. Last part are all those equations. Okay? First ones are pretty simple. Here I am right here. Everybody see them? Okay, I'm going to write this over to the side of my paper so I can have more room to work it out. Square root of x minus 15 equals 3 minus the square root of x. I'm going to do this one first. What do I do to solve for x? Anybody? Square everything first. The only way I can get rid of these square roots is to square it. But if I square this one, I have to square that. So I have to square both sides. That's really no good to add this over here. I'd have to square that side anyway, right? Okay, so if I square this, I end up with just x minus 15. How do I square the right side? Foil. Foil. I know. Everybody always says that when it's... If it was written like this, you would tell me for sure, oh yeah, coach, that's a foil, right? But for some reason, when it's written like this, make sure you understand it's still foil. A lot of kids do that wrong. Oh, I'm sorry. Okay, I'm going to foil this. Let's see, 9 minus 6 square roots of x plus x. I did that in my head. This is the first. I combine the like terms, the inside and the outside. That's the last. Okay, what would I do from here, guys? I'm solving for x. I have to get this term by itself because this is the one that's still like messed up, right? That one still has a root in it, so I have to get it by itself. Okay, so subtract these x's off. If I put that over there, that's negative 24. Divide by negative 6, which is 4. Oh, looky there. Am I good now? Square both sides. X equals 16. Yes? Do y'all need... Huh?
There was a question like that on the SAT yesterday.
Yay! Did you get it?
No.
You didn't?
I tried it 3 different ways.
That makes me
and
so excited.
I did it this way,
Uh-huh.
but I must have done something wrong, and I didn't have enough time to go back and...
Darn
fix
it. But you knew what to do.
I knew what to do.
It was exactly like this? No kidding.
It wasn't the same question, but it was this method.
Solving an
Yeah.
equation with... Really? And you had to square both sides? Really? Okay. Now, I was so excited. Okay. I know. I live in the math world, guys. Sorry. Stuff like that makes me excited. It is on the video. Okay. Now, I have to check for extraneous solutions. Let's come back down to earth, people. I'm going to mentally plug this back in and make sure I don't come up with something that's not valid. Just because this says x equals 16, you have to plug it in to make sure it works. Because we're talking about square roots, right? Square roots can have values that are not in the real number system. All right, 16. I'm going to plug this in right here, right? What's 16 minus 15? Square root of 1 is good, right? Square root of 16 is 4. Is 3 minus 4 the same thing as, this side ended up to be positive 1, though what side is, this comes out to be negative 1. No solution. Yes. Okay, how many questions I have left? Like 3? Huh?
Yeah, you have 29, 42, 51, 57.
Oh, gosh. Okay, really fast on number 29. 29. This is actually a pretty simple version of this type of question. Y'all realize you have to get this by itself first?
Yep, -6.
Square both sides. Square both sides. Going through this kind of fast. 4x plus 8 equals 9. Solve for x. X equals a fourth?
Yep.
I think it's a fourth. It's a pretty level 1 question compared to the one I just did. Okay. All right, look at number 42. This was in the same lesson. I chose this one because it's written, it has a fraction exponent. You can either solve it like this, or you can rewrite it with a root, whichever is more pleasing to you, to the eye, right? But either way, guys, I have to get this by itself. So subtract 4 to both sides. 2 times x minus 10 to the 1/3 equals -4.
Divide by 2.
Divide by 2.
Square.
If I wrote this as a root, third root, I would be cubing both sides. If it's a 1/3, I'm still going to be cubing both sides. Some of y'all didn't do these questions from the book, but you should understand the idea, right? So I'm left with x minus 10 equals, guys, what's -2 to the 3rd power? -8. So my answer is +2. Does that work? Is it +2? 2 minus 10 is -8. Third root of -8 is -2. 4 times -4 plus 4 is 0. Yep, I just did it in my head. Okay, I chose this question to make sure you understand it's the same kind of question, even if it's written with a fraction exponent. All right, the last 2 questions are the ones with inequalities. Hopefully I can at least get through one. I don't think I put this as a free response. It's just a multiple choice question. Okay. Yay. Okay. Am I on the screen for everybody? Okay, same idea as before. I have to get this by itself. Same idea as before. Add 6. Square both sides. Sorry, I'm not on the screen for everybody. Square both sides. Gosh. Is it okay? Sorry. Square both sides.
2x plus 14, 100.
Subtract.
14,
Minus 14.
86. Divide by 2.
43. Okay, guys. It would be mathematically impossible to check every value greater than 43 into there to see if we have any extraneous solutions. Okay, but I do know that all the x's that make this expression negative are not valid. Okay, so all I'm going to do is take this expression that's underneath the root. Those numbers need to be greater than or equal to 0. So that my root ends up to be positive and it's not an imaginary number. Got it? Oh, Oh, coach, I did that math in my head and then wrote it. So not only do the x's have to be greater than or equal to 14, they also have to be greater than or equal to -7. So does it work? You have to think about this as a compound inequality. Let's visualize what this is. Okay, right now, when I solve that, I need all these values, right? They also have to be greater than or equal to -7. Oh, but we're okay, right? Are all these numbers greater than or equal to -7? Yes. Ends up to be a compound inequality. This question is not a free response one. I think it's just a multiple choice. So with the answer choices, you should be able to figure out which one works.